Type TI-21 is an audio frequency track circuit, joint-less insulation rail joints not required when used on straight portion. Two types of track circuits: end-fed, center-fed. The main difference between the two types is the feeding arrangement by which they operate. It is available in two configurations: decentralized configuration, centralized configuration. This system includes the transmitter, transmitting end cables, tuning unit at transmitting end, bonds on rail, tuning unit at receiving end cables, receiver, lightning arrestor, line matching unit, impedance bond, track relay. Features: ABB TI-21. Minimum ballast resistance equal to 2 ohm per kilometer. Train shunt resistance equal to 0.5 ohm outside the tuning zone. Train shunt resistance equal to 0.15 ohm inside the tuning zone. Power consumption equal to 4.4 ampere at output. Rail types equal to 90 pound, 52 kg, 60 kg. One transmitter can coupled with maximum 2 receivers. Remote feeding equal to 3 km, 0.9 mm diameter quad cable. Cables for feed in and feed out equal to quad cable, 0.9 mm diameter copper conductor as per specification IRSTC 30/96. Modulation type: frequency modulation. Modulation rate equal to 4.8 Hz. Frequencies: there are total 8 operating frequencies in the range of 1.5 kHz to 2.6 kHz. Operating frequencies as per given table. Frequencies at gap of 597 Hz in one pair. Length of tuning zone equal to 18 meter to 22 meter, 19.5 meters. Length of track circuit. Remote feeding depends upon distance of track unit from equipments. For less than 300 meter, signaling cable can be used. Transmitter TX board. The multivibrator produces a square wave with a frequency of 4.8 Hz. The square wave is fed to the modulator, which modulates the output of the oscillator and produces a signal that varies by plus or minus 17 Hz of the carrier frequency at a rate of 4.8 Hz. The output amplifier increases this signal to a power level suitable for the transmission to the track. Matching transformer matches the amplifier output to the load. The output filter isolates the unit from unwanted DC and AC voltages. Output signal is fed via 2-core cable to the associated tuning unit TU or end termination unit ETU or track coupling unit TCU. Receiver RX board. The receiver RX has 2 parallel channels, one tuned to the higher frequency F+17 and other to the lower frequency F-17. In each channel, the signal is filtered, amplified, again filtered, and finally demodulated so that a pair of anti-phase square waves are applied to the AND gate. The AND gate gives the required constant negative output only when both waves are present in antiphase to each other. This negative output is fed to a capacitor timer which requires 2 seconds to reach a high potential to produce 50-volt relay drive. Power supply unit, transmitter TX and receiver RX are designed in such a way that they do not require regulated power supply. The regulation is provided inside the transmitter TX and receiver RX itself. Hence, the power supply used for TI-21 is simple unregulated power supply. As shown in the schematic diagram, it consists of a 110 or 24-volt transformer, a bridge rectifier which converts 24-volt AC to 24-volt DC, and a filtering capacitor which reduces the ripple voltage in the 24-volt DC supply. The power supply is rated for a maximum output of 4.4 ampere, thus permitting up to 2 transmitters TX or up to 8 receivers RX or any suitable combination of transmitter TX and receiver RX to be powered from one unit. It should be ensured that no two equipment of the same frequency should be powered from the same power supply, and the rating of the power supply unit PSU is not exceeded. Specification: input voltage 110 volt AC nominal, 50 Hz plus or minus 2.5 Hz. Input tappings 5, 0, 85, 95, 105, 115, 125 volt. Input variation plus or minus 9% of selected tapping. Output voltage 22.5 to 30.5 volt DC. Output current 0.25 to 2 ampere, 2 to 4.4 ampere, depending upon the selected tapping. Output ripple maximum 2 volt peak at full load current. Tuning unit. Purpose of TU, ETU and TCU is same. These are passive devices which consist tuned circuit and used to form electric separation joint ESJ. TU, tuning unit. ETU, end termination unit. TCU, track coupling unit. TU is used in continuous track circuit. ETU is used at end fed or end receiver, adjacent to insulated rail joints, center fed arrangements. TCUs are now being used instead of ETU. Tuning unit TU. It is a passive device. It consists of a tuned circuit which is used to form the electric separation joint ESJ. End termination unit ETU. It employs the same housing as tuning unit and the same terminations. Specifications of TU and ETU. Maximum permissible rail to rail voltage 110 volt AC or 160 volt DC. Mounting vertical. Maximum length of track to tuning unit TU and end termination unit ETU cable. Long cable 3.95 meter plus or minus 0.02 meter. Short cable 2.35 meter plus or minus 0.02 meter. Track coupling unit TCU. TCU is a passive device. It can be used to terminate the track circuit. It consists of a capacitor, resistor and a transformer in series. It is basically a band pass filter tuned at a particular frequency. The major applications of TCU are as follows. To terminate a track circuit, in the point zone track circuit, in the yards where it is difficult to form the tuned zone. The advantages of using TCU as compared to ETU are as follows. The main difference between TCU and ETU is that TCU can withstand 400 volt DC / 275 volt AC RMS as compared to 160 volt DC / 110 volt AC RMS for the ETU. Hence, TCU can be used for single rail application. TCU can be kept at a distance of 130 meter from the rails. This facilitates the use of TCU in complex yards where there is a space constraint. With TCU, it is not necessary to use 35 square millimeter cable for connecting TCU to rail. 2 into 2.5 square millimeter can be used. Impedance bonds are not used with TCU but are used with ETU. Specification of TCU. Maximum rail-to-rail volts 400 volt DC or 275 volt AC RMS. TCU to track cable 2 into 2.5 square millimeter copper cable, 2 core 35 square millimeter copper cable, 50 square millimeter equivalent aluminium. Maximum distance of TCU rail connection to block joints 1 meter. Line matching unit. Line matching unit is a transformer used to reduce the transmission losses. It is used only for centralized version and in distributed version only when distance of transmitter to TU/ETU/TCU is greater than 30 meter. Further, it is to be used with the transmitter TX only and not with the receiver RX. There are two types of LMUs as follows. LMU TX side. It is connected to the transmitter in the equipment room. LMU TU side. It is connected to the tuning unit TU located at site. In the equipment room, the LMU TX side boosts up the transmitting voltage, thus reducing the current. This signal is transmitted to site where LMU TU side steps down the voltage and feeds this signal to the corresponding tuning unit TU or end termination unit ETU or track coupling unit TCU. This arrangement helps to reduce the I2R losses and thus achieve longer feeding distances. Specification. Transformer for LMU. Tapping details. Primary 0 to 10.5 volt and secondary 0 to 90 volt. DC resistance of each winding, primary 0.14 ohm and secondary 10.7 ohm. Node load current 42 milliampere maximum at 1.5 kHz, 35 milliampere maximum at 2.6 kHz. ESJ. Electric separation joint comprises of two tuning units of two track circuits of different frequencies. Properties of ideal separation. Minimum crossover length or overlap. Minimum signal flow allowed in the reverse direction. Detection of joint failure. Each tuning unit TU presents low impedance to the frequency of the adjacent track circuit. For example, the tuning unit of A frequency will present low impedance to the B frequency signal, while tuning unit of frequency B presents low impedance to the A frequency signal. The inductance of the rails between the two tuning units is tuned to high impedance for both the frequencies present by means of net capacitive reactance in the tuning units. Each tuning unit tunes the rails to its associated frequency. This results in the directional transmission or reception. The receiver RX is always connected to the terminals 1 and 2. The transmitter is connected to the terminals 4 and 5 for normal power mode, track circuits lengths of greater than 200 meter. 1 and 2 for low power mode, track circuit length of 50 to 200 meter. The overlap zone of the tuned track circuit is measured from the point midway between the tuning units. Within this region, both the track circuit may be de-energized by a shunt. The length of the overlap zone depends on ballast conditions. ESJ must be bonded with minimum size 150 square millimeter copper cable or MS strap, which should be welded or braced or pin bonded to the rail. Indoor equipments. In centralized configuration, following precautions should be taken while installation of centralized version. TI-21 power supply unit PSU can be used to supply any combination of transmitters and receivers provided its 4.4 ampere rating is not exceeded and all transmitter TX and receiver RX frequencies are different. The factors regarding allocation of equipment in the quad cable and the distance criteria should be considered. In the centralized location, the transmitter, receiver, power supply unit, lightning arrestor, relay and LMU-TX are installed on a rack. Track relay. TI-21 ABB receiver generates 50 volt DC. This can directly be used to feed a 50 volt DC relay. Metal to carbon relay or metal to metal type TMA relays can be used with TI-21 receiver. Specification. Maximum voltage across windings for full operation 40 volt DC. Minimum voltage across winding for release 7.5 volt DC. Minimum voltage for full release 4 volt DC. Maximum power dissipation 3 watts. In decentralized configuration. In decentralized version, all the equipment are located at site. The transmitter, receiver, power supply unit are mounted on a wooden plank inside the location box using fixing angle provided with them. Following precautions should be taken while installation of distributed version. Transmitter and receiver locations must be positioned as close as possible to the TU or ETU or TCU. The distance of cable from TU or ETU or TCU to TX should be less than 30 meter. The distance of cable from TU or TCU to RX should be less than 350 meter. Two units of the same frequency TX and RX may be housed in the same location provided they are fed from separate power supply units. TI-21 power supply unit can be used to supply any combination of transmitters and receivers provided its 4.4 ampere rating is not exceeded and all transmitter and receiver frequencies are different. Tuning unit. As per SEM 2 para 17.5, permanent way requirements of track circuits must be followed. The mounting of the tuning unit and end termination unit should be vertical. As per SEM 2 para 17.19.7.3, special precautions shall be taken to ensure the tightness of connection of rail and tuning unit. Connection to rails is done using a L plate and 2 paper. Alternatively, the connection can also be done using cat welding, pin brazing or any exothermic welding technique. Earth connection in tuning unit shall be done as per OEM manual. Laying bonds. While installing, the Z-bond care should be taken to ensure that one connection of the TU to rail is done through Z-bond. So in case Z-bond gets disconnected from rails, the TU will also be disconnected from rails and thus it will be protected against possible damage due to imbalance in traction return current. Cable terminations. Internal wiring is done using 1.5 square millimeter multi-strand copper cable. 0.9 millimeter diameter quad cable is used for feeding from transmitter to tuning unit and from tuning unit to receiver. Quad cable from outdoor is terminated on CT rack in equipment room. Precautions for quad cable. Separate quad cables should be used for transmitter and receiver. All transmitter of any frequency can be combined in one quad cable, and all receiver of any frequency can be combined in another quad cable. If, as a special case, it is required to take transmitter and receiver in the same quad cable, then they should be of different frequency. For transmitter, single pair of 0.9 mm diameter quad cable can be used for a feeding distance up to 1 km. For feeding distances more than 1 km and less than 2 km, double pair in parallel of 0.9 mm diameter quad cable should be used. For receiver, single pair of 0.9 mm diameter quad cable can be used for a receiving distance up to 2 km. For receiving distance more than 2 km and less than 3 km, double pair in parallel of 0.9 mm diameter quad cable should be used. For distances less than 300 meter, signaling cable can be used instead of quad cable. However, for each equipment, separate cable should be used. In centralized version, the distance of nearest location box where quad cable is terminated from TU or ATU or TCU should not be greater than 100 meter. The connection between the location boxes and the tuning unit, end termination unit and track coupling unit is done using 2 into 2.5 square millimeter copper wire. 35 square millimeter copper or 50 square millimeter aluminum cable is used to connect TU to rail. Termination with non-tracked circuited area. When track circuiting with TI-21 ends and there is no further track circuiting the arrangement, here a 150 square millimeter copper cable or MS strap is connected across the rails. Note that the tuned rail length is shortened to 17.8 meter to account for the inductance of the shorting cable. In non-electrified area, 35 square copper millimeter cable can be used for shorting purpose. Fail-safe adjustment. Gain setting in receiver. Procedure: initially set the gain of the RX to 13 as shown in the table below. Measure the voltage drop in millivolt AC across the 1 ohm input resistor. This reading will give the input current directly in milliampere AC. Using the following table, select the nearest reading and set the receiver for an initial relative gain. The final gain setting is done only after conducting TSR test. Gain equal to 390 per volt, where V the voltage across the 1 ohm resistor at gain setting 13 in millivolt. For gain of 13, the track circuit will operate from 15 milliampere to 60 milliampere. This is the dynamic range of the track circuit. Modes of operation. Normal power mode. This mode is used for longer track circuits having length more than 200 meter. For normal power mode, the transmitter is connected to 4 and 5 terminals of tuning unit or end termination unit or track coupling unit. Low power mode. This mode is used for shorter track circuits where length varies between 50 to 200 meter. For low power mode, the transmitter is connected to 1 and 2 terminal of tuning unit or end termination unit. Track circuits using TCU in transmitter and track circuits with Z bonds are always connected in normal power mode. For both low power mode and normal power mode, the receiver is connected to 1 and 2 terminals of tuning unit or track coupling unit. Parameters. Input to PSU is equal to volt AC, 110 volt AC plus or minus 10%. Output of PSU, volt DC, 22.5 to 30.5 volt DC. Current consumption on 24 volt DC side. Tx equal to 2.2 ampere maximum. Rx equal to 0.5 ampere maximum. Readings at transmitter end. Tx input equal to volt DC 22.5 to 30.5 volt DC. Tx output volt AC 10 to 11 volt AC or 15 volt to 16 volt AC. Frequency equal to measure the frequency. Note: singing noise should be heard. Voltage across rail volt Tx. Vtx equal to 0.8 to 1.8 volt AC for low mode, 4.5 to 7.5 volt AC for normal mode. With 0.5 ohm TSR, Vtx equal to V should be reduced to 50%. Note: rail to rail voltage. Ratio voltage at adjoint track 1/12th of normal value A, C, E and G, 1/18th of normal value B, D, F and H. Receiver end readings VRX voltage across rail equal to measure the voltage AC 0.5 to 0.8 volt for low mode, 0.4 to 1.6 volt for normal mode. Do's and don'ts. Do's: point zone track circuits having Z bonds, and track circuits using TCU in transmitter are always connected in normal power mode. For decentralized version, when LMU is not used, ensure that the maximum distance from TX to TU or ETU or TCU is not greater than 30 meter, and for RX to TU or ETU or TCU, the maximum distance is not greater than 350 meter. When wiring and installing the track circuits, circuit pairing should be observed in the line cables. After gain setting, do the TSR test compulsory. Replace fuses of proper capacity. Don'ts: don't run transmission and reception with the same frequency within one same cable. Don't run the cables connected to TU unit and rail in zigzag manner. Don't use power supply unit for TX and RX of same frequency. Don't forget to connect one connection of tuning unit to Z bond. Don't use LMU to RX side. Others. As per letter number 2007/W/5/1 AFTC dated 26/7/2007. ABB TI-21 is not recommended for point and crossing. Also, modifications are required for lightning protection at various stages. Z bond is also not validated. Failures: if OHE must is connected to rail length of track circuit will get reduced.